Hello students, today I'm going to be discussing properties of rational exponents. We're going to be using a lot of the same properties as regular exponents. The first property I'm going to look at is if we have a to the m times a to the n power, we are going to add our exponents. And remember that this has to be the same base in order to do this. An example of this would be if we have 5 to the 1/4 power times 5 to the 3/2 power. We need to add our exponents. We notice that these are the same base, so we need to add our exponents. And when you add fractions, you have to have the same denominator. So I'm going to multiply by 2 over 2. So I have 5 to the 1/4 power times 5 to the 3 times 2, which would be 6, and then 2 times 2 would be 6/4 power. Now I need to add my exponent, so 1/4 plus 6/4 is going to give me 7/4. So my final answer is 5 to the 7/4 power. The next property I'm going to look at is if I have a to the m raised to the n power, I'm going to multiply my exponents. An example of this would be if I have 3 to the 5/2 power raised to the second power. I multiply my exponents, so 5/2 times 2 is going to give me 3 to the 10/2, and I can simplify that to 3/5. And if I put 3/5 in my calculator, or 3 to the 5th power, I'm going to have 243. The next property I'm going to look at is if I have is distributive. So I have a times b to the m power. So I know that it's a to the m and then b to the n. So if I look at an example of this, I have 3 to the 1/2 power times 4 to the 1/3 power, all raised to the second power. I need to distribute the squared power, so I have 1/2 times 2, which would just leave me with 6 to the 1st, and then 1/3 times 2 would leave me with 4 to the 2/3. Because these are different exponents, there's nothing further I can do besides just clean it up a little bit, so I have 6 times 4 to the 2/3 power, and that would be your final answer. The next property is if I have a to the negative m, we know that the negative exponent comes into the denominator. So an example of this would be if I have 36 to the negative 1/2 power, I know this negative exponent moves this whole thing to the denominator, so I have 1 over 36 to the 1/2 power. And I know that the 1/2 power simplifies to the square root, so it's 1 over the square root of 36, and I can simplify that further to 1 over 6. The next property I'm going to look at is when I am dividing, so I have a to the m divided by b to the m, so I need to subtract my exponents, and remember that these must be the same base. So we have an example of this. If I have 5 over 5 to the 1/3 power, I need to subtract my exponents. So I have 5 to the 1 minus 1/3. Anytime you subtract fractions, you have to have the same base. So I'm going to multiply this by 3 over 3. So I have 5 to the 3/3 minus 1/3, so that's going to leave me with 5 to the 2/3 power. And the last property we're going to look at is a to the b, or a divided by b, all to the m power. And I know that I need to distribute this, so I have a to the m over b to the m. So an example of this would be 42 to the 1/3 power over 6 to the 1/3 power, all raised to the second power. There's two different ways I can solve this. The first way is because these have the same exponent, I can go ahead and divide 42 by 6. So I get 7 to the 1/3 power all raised to the second power, and go ahead and distribute that 2, so I'm going to get 7 to the 2/3 power. The other way I can look at this is if I go ahead and distribute my 2 originally. So come down here, and I have, it would be 42 to the 2/3 power, because the 2 times 1/3, as well as 6 to the 2/3 power. Once again, because these are the same exponent, I can go ahead and divide, so I get 7 to the 2/3 power. If you notice, you get the same answer, just looking at it a different way. I'm going to go ahead and do one more example dealing with distributive when you're multiplying. And with this example, I'm going to have 4 to the 5th power times 3 to the 5th power, all raised to the -1/5 power. I want to show you this example because it applies because we have the same exponent. So if I multiply 5 times -1/5, I can get 4 to the -1st power. Same thing, 3 to the 5th times to the -1/5, I'm going to get 3 to the -1st power. And if I go ahead and use properties of negative exponents, I have 1/4 times 1/3, which gives me 1/12. There's another way I can look at this. Because they have the same exponents, I can go ahead and multiply these numbers within. So 4 times 3 gives me 12 to the 5th power, raised to the -1/5 power. So 5 times the -1/5 would give me 12 to the -1st power. And I know using properties of negative exponents, that would give me 1/12. And if we notice, those are the same thing. That's all the examples for today. If you have any questions, we'll go over that in class.